Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, I'm going to talk about the topic from 3.17, the temperature effects from the chapter 3, load and stress analysis from Shikli Mechanical Engineering Design textbook. Okay, this is the subject for engineering students related to this subject matter. I hope you can get the book with you because you can learn better lah if you have the book with you. Okay. So the temperature effect. This is a table which is the coefficient of thermal expansion from the material. Okay, some of the popular materials such as aluminium, brass, carbon steel, cast iron, magnesium, nickel steel, stainless steel and tungsten. Okay, this is the Celsius and this is the Fahrenheit reading on it. Okay, this is the coefficient of thermal expansion. We are talking about thermal expansion for this. Okay, so you can see the material temperature and material expansion. Okay, talking about material expansion. Okay, when we heat something, it will expand. Okay, the same goes for the material steel because this subject dealing with a lot of steel. Okay, now we're talking about steel. Okay, it will have expand. It will be expand because of the heat from the sun. Okay, let's say the temperature of the sun normal on in the middle of the open area, the sun come, it will expand. This in machining, when the material is rotating or is vibrating and everything, it will give the vibration, it will give the heat, and that heat will make it expand. Okay. Okay. This is we're talking about expansion. Uniform expansion where temperature is of an unrestrained body rises uniformly. It expand in all direction. What does mean by unrestrained body? Meaning that that material, that steel, that rod, let's say for example the rod of the steel rod, the cylindrical rod, you put on in an open area like a field, like a football field and everything, it will expand because it will uh, no no restraint lah on it. Okay, suppose you put some assembly, bicycle lah, you put the bicycle has assembly, all the screws, all the parts, everything. You put the bicycle on the field, you expose it into the sun. Okay, uh, what will happen is when its expansion come to the screw, it will become restrained. It become restrained. Then it cannot be expand. That's why you can see the warping. Okay, the warping mainly the material become buckling. Okay, uh, normal straight in x y z direction in x y z, apa sigma perubahan uh, uh, T, okay, where alpha is the coefficient of thermal expansion and apa, I don't know how to say in English, but it's a perubahan T lah, perubahan temperature is the temperature change, okay. Proportional increase, okay, dimension increase proportionally with temperature. No shear strain occurs as volume increase without distortion. Okay, this is the for unrestrained. Okay, this is the restraint in thermal stress in bar. Like say for example, you put a bar. Just now I give an example. Uh, just imagine you put a bicycle, okay, on the an open field exposed to the sun. Okay, the bicycle have screws, everything. The bicycle have screws and everything. That is a restraint bar. Okay, it will become theoretically it become buckling lah. Okay, from that part they become restrained, become buckling. So it become compressive stress formation at when a restraint bar is heated, it develops compressive stress as especially limited by external restraint. Thermal stress is defined by this equation. You can find the textbook. Where E represented with the Young modulus. That Young modulus is be covered in the earlier section of this book, which is chapter 1. And structural impact unaddressed thermal stress may cause buckling in structural components like steel beams. Okay, so it become buckling. So you see the part that become restrained to become slightly larger. Okay, upon time lah. Then we go for the thermal stress in flat plates. Okay. So restrained plates, when a plate with fixed edges is heated, the compressive stress develops across its surface due to restricted expansion. Okay, shear stress formula, stress is calculated by this equation where V is representing Poisson ratio, and application in electronics. Thermal stress consideration are critical, like component like circuit boards can wrap under heat. Okay, so this is what is flat plate. The picture here, if you are is aware of it, it is the chair that you find in the airport and everything, kan. Usually this kind of chair lah, that has the but have the holes in it. Okay, so that this kind of chair, yeah, you can see in the airport. Okay, waiting lounge in the airport. Okay, or at the bus stop and everything. They have the structure. It also have restraint. Okay, because it will become a screw. At some parts will become a screw, one, two, three, four screw and everything. So the place that become screw become restrained. Okay, so a plate is with fixed edges is heated, compressive stress develop across its surface due to resistive infection. Uh, Upon over time, over a long time, when it's supposed to heat, it's supposed to solar, it's supposed to the sun, okay, the matahari, and then it will become raw pink. Okay, become raw under heat lah. Okay, the stress formula is calculated by this equation. So VV representing Poisson ratio, application electronic, as the electronic part is very critical because it's so sensitive with the heat electronic part. Maybe we seldom see in the normal life, but for electronic part, like the things that you have in your handphone, smartphone, everything, they have electronic parts. Okay, so think that's all for the video right now. Okay, inshallah we meet in the next video. Okay, I will post this video in this channel lah. Okay, thank you very much. Okay, inshallah we meet again.